Okay, well, here's your answer to your quiz right here. So the right arrow is how we determine the return type, or how we mention what the return type will be for a function in Swift. Okay, just so I don't forget, the next assignment is already up, and it's due on Wednesday, and it's going to cover what we're talking about today. So I'm going to cover objects and stuff initially today. Then we're going to start talking about iOS development in general, kind of how it works at the high level. And starting Wednesday, we'll probably do our first Apple Watch application. I probably won't be able to give you a homework assignment until Friday for Apple Watch, but I'll give you some other homework assignment before then, because Apple Watch 2.0 drops on Wednesday morning, which means Xcode 7.0 drops on Wednesday morning, which means that we'll have to get it downloaded and installed in the lab. But the rest of you can go ahead and get on your computers starting then. All right. So what we're going to talk about today initially is the idea of objects. All right. So, and again, for most of you, this is review. For those of you who are in the 250 class, we're kind of doing things a little bit out of order, but you seem to be the brighter folk from that class, not the steerage. So we'll just pretend you've seen this stuff before. So when we talk about objects in any object-oriented programming language, these are really objects that could hold 0 or more values and potentially do more. Okay, so we're going to say things that can hold 0 or more values and potentially do more. So that would be the generic definition of an object. Okay. Now to get a little bit more specific, objects are made up of these three things. They're made up of constructors, fields, and methods. All right. So in Swift, they call methods functions. Okay, but same diff. They're all reusable chunks of code. You write once, call as many times as you want. Right, so these are the types of animals that live inside of an object. All right, generic syntax for objects in Swift is going to be very familiar to many of you. So we have class, object name, opening curly brace, closing curly brace. Should look extremely similar to how you define a class in Java. In fact, identically. It should look identical. All right, so that's, I like to think of these as kind of like garbage bags, where this is the outer garbage bag. Something like that. I'll take the comment out here in a second. Let's just shrink it down a little bit. There, good enough. All right, so all of those constructors, fields, and functions, methods, are going to go inside of this opening and closing curly brace when we deal with objects. Okay? Now, what are fields? Fields are a fancy way of saying what? Variables that belong to the object. That's what a field is. Variables that belong to the object. Well, we've already defined what functions are. So functions, these are functions that belong to the object. And they come in a couple of different flavors, but for right now, we're just going to deal with plain Jane. Typically, there's kind of two separate objects. We have objects with static members and objects with non-static members. For right now, everything's going to be non-static members anyway, so we're just going to pretend like that's all that exists. For those of you who are in 250, you'll understand what static and non-static members is in either this week or the next. All right, so unimportant for you, just functions are functions. What's the job of a constructor? Go ahead.
To set up your object.
Okay, to initialize the starting values for an object or something like that, right? So for example, your homework assignment tonight is to make a fraction object and then make it do some stuff. Okay, so for instance, if you were initializing a fraction, fractions require a numerator and denominator, right? So we're probably going to have a couple of fields, a field for the numerator and a field for the denominator, so that a fraction can remember what its numerator and denominator are. And then the constructor for the fraction class will probably take in a numerator and denominator to initialize the starting values for those fields. Make sense? Now, in Java, constructor, so here, this is a method-like entity that sets up the initial values of an object. Typically, we would say this sets up the fields, but it could also do some other logic stuff in there and things like that. But unimportant for us now. It's the thing that initializes it. Okay. Now in Java, constructors must always have what? So in Java, if I was writing a constructor for this particular class, what would I have to say? What's the name of the constructor for the class object name? So for instance, let's just say that our object name had a single string called a value. And maybe this guy takes in a string s, and we set a value equal to s as a starting point in Java. Make sense? So this is Java. It's not even pseudocode. This is Java code. But let's look at the equivalent of this in Swift. So in Swift, this would be var a value colon string. We can optionally have that for right now. Let's just leave it off, not to confuse things. The constructor must always be called init in Swift. All lowercase, one word, init, because it initializes. All right, and then the parameter this guy's going to take is it's going to take, actually it doesn't say var, it's just s colon string like that, right? Pretty sure. And then we'll say a value is equal to s. All right, so pretty similar to Java, but little syntax change. Make sense? So what do we got on our screen over there, Abe? Notes? So what are we smirking at? I got something come out of my nose?
A little bit, actually.
Really?
It's up there a little. Other side.
How far?
I mean, I could get it with my tongue.
That's recorded. Let's see. Whose quiz is this? All right, so this makes sense? Difference between these two?
So if you don't take in any parameters, can you just not have a init?
Correct. You can avoid having an init if you because in Java, just like in in Swift, just like in Java, every object inherits automatically. I'm going to kind of write something here. So let me take out my long comment here real quick. Do the same thing down here. In Java, we might say that object name actually does something called extends object. Although we don't write that, because in any object-oriented language, we have a hierarchy, and at the very top of that hierarchy is this generic object thing, okay? So in this particular case, in Java, that's assumed to be there, but we don't actually write it, okay? The same thing's true in Swift. Swift, we don't actually write what class it comes from. Now that isn't to say that it doesn't still inherit from that class. So in Swift, if we don't write an init function ourselves, one will be provided for us that does nothing. Similarly, we could do some specialized stuff and then still do something like this. Actually, that would have to come first in Swift and Java. If we really wanted to call upon our parents constructor and then do something a little extra, we can do that. Call upon the parents constructor. Okay, but for right now, we're keeping it pretty simple. We're not dealing too much with inheritance or anything, just how do objects work at the lowest level, I guess, in Swift. All right, make sense? All right, so let's go over to the playground and let's look at this. And we're going to create a person object. Do I not have Xcode opened? All right, so we're going to go ahead and create a class named person. And we're going to start off by saying var name is a string. Just keep it simple like that. And we'll say var p1 is equal to person. Var p2 is equal to person, except no semicolons. P1 dot name is equal to Mike. Let's see what it's screaming about up here. Class person has no initializers. Do I need to say NS object? I might have lied to you, Dave. Looks like I did lie to you. It does need to have a constructor. I didn't think you... Oh, yeah, so this is a thing. All right, so in Swift, we have a kind of a specialized syntax. The same thing is true for our functions in Swift. We don't give types. It has a type inference engine at the time a value is initially set. And this is kind of where it gets a little bit weird in Swift. So in this case, I have a variable name that is of type string. Well, when I only have one variable, when I go and create this guy, you'll see it automatically does it for you. When I do person, open parenthesis, notice it gives me the constructor format for that. So I have name, and we'll say the name of this guy is Mike. Similarly, right here we have name, Dave. All right, so that creates our two people. That's part of the syntax, is this, in some languages they're called decorators, but decorators have actually got turned into something else. So I'll just call these descriptions, variable descriptions. So for both of these guys, this guy has a name Mike and a name Dave. Now what I'm going to do is I'm going to change our object up a little bit here, where we're going to have an F name and we're going to have an L name. And we'll have this guy take in an F name as well as an L name, both of type string. And we'll say self.fname is equal to fname. Self.lname is equal to lname. Self, did we already talk about self in here? Okay, well, I'll just write it again real quick, just as a reminder. Self is how a object refers to itself from within itself. Same as this in Java. Okay, they're equivalent, so those of you who are learning Java at the same time, self and this, same deal. Without the use of self here, we would not have had, we could not have named our variables here fname and lname because we already had a more global fname and lname. That's the variable scope thing. Okay, so we had to differentiate and say this particular object, self's, my fname, this guy up here, is equal to the fname that was just passed in. My lname is equal to the lname that was just passed in. That's how we differentiate those. Bad programming practice would be to change your variable names down here so that you don't have to pass in descriptive ones up here. Variable names should always be descriptive. They should always be self-documenting. So if you want to store the first name and the last name, fname and lname make pretty good sense. If we change this guy here to like fn, where we wouldn't say fname here, we'd say fn, and then we wouldn't actually have to say self dot because it would be able to differentiate those. That would be considered bad programming practice. You modified the name of the variable just so you didn't have to use self dot. We should understand what self dot does. It's how we give the full path to our variables that we own. That is the fields that are owned by this object. All right. So now notice it's yelling at me down here because my new constructor takes in 2 parameters, not 1. So let's go ahead and back off here just to show you how it auto-completes. So open it up. So it takes fname and lname. So we'll say Mike. Just stop it right there like that. So that's fine. Oh, I used to think that maybe that's just for functions, not constructors. All right, well, we'll see if that plays out with a function. We'll write a function here in a few minutes as part of this. But my belief is, at least maybe in Swift version 1, that when you have more than one parameter, at least in normal functions, not constructors, constructors are kind of special animals, that this part of it is optional. You don't actually have to give for the very first parameter. All the other ones you have to give it. You have to put that value in. But we'll see if that comes out to be true. All right. So this is how we would define our object. So objects are kind of like methods from the perspective of they're an untapped resource until we actually use them. So this is the object definition. Here's us actually creating a variable which holds an instance of one of those objects. This particular instance has Mike for the first name and Littman as the last name. So I can say something like println p1 dot fname. It'll look like that. Okay, and by the way, on Wednesday, println goes away. I think it's just print now. They don't have 2. I think they just have 1.
So what does print do then? Does it do it?
Prints it on one line, and I don't think it automatically kicks it down to the next line. I think you would have to concatenate on the \n. That's just based on me testing the new beta of Xcode 7. Keep in mind that Swift wasn't a language that was made necessarily for console output. We can do console output with it, but it's really designed for, making iOS apps do stuff. Okay, so we're pretty quickly going to be moving away from printing stuff out to the console and instead making a label say something, okay, or something like that on the screen. All right, but in any case, we'll burn that bridge when we get to it. Not a big deal. So this prints P1's fname. I could also print P1's lname. But what we're going to do is we're going to go ahead and we're going to add a function here to our person class. So again, objects are collections of fields, constructors, and functions, or methods, okay? So here's a couple of fields. Both of these guys are fields. This guy's a constructor. Okay, now we could have multiple constructors. We could have another constructor that takes in no parameters and sets self.fname equal to n/a. Self.lname is equal to n/a. So then technically we can build a second variable, var p2 is equal to a person. And notice we have two choices for creating people. We have a person that takes no parameters, the constructor takes no inputs, and then we have a version that takes two inputs, a first name and a last name. So if I make this guy the one, if I use the one that takes no parameters, it will call this version of my constructor. So it differentiates the constructors based on the parameters it takes, name and number, the type and number of parameters. So if I were to print P2's F name, it's going to get n/a, because that's what I defaulted it to. Make sense? All right, so what's it called when we have more than one function with the same name but a different number and or type of parameters? Polymorphism. All right, so here's an example of polymorphism with constructors. But in our case here, two constructors probably doesn't make a whole lot of sense, just like it won't make sense in your homework dealing with fractions, so we'll take the second one off here. And let's go ahead and let's write a, let me just delete some of the stuff down here. Let's go ahead and write a function that displays a person. All right, so we're going to have a function, and functions always start with, and we talked about this last time, the word func, right? And then the name of the function, display in this case. Now display for us is going to take no parameters because we want a person to be able to display themselves. And a person already knows about their first and last name. We don't have to tell them what person we want to display. They already know that information. All right, so we're just going to call it display, and it's going to return nothing. It's possible that should be a capital V, but we'll see shortly. All right. I'm going to make some issues like that. As most of you know, I program in about 10 different languages on a given week, so I'll be fine. Once we get into Swift mode, we'll be fine. All right, so display, this guy returns nothing because that's what this arrow, this was today's quiz. What does the arrow mean? This says what will the return type of this function be? This one's void, which I think, was it Nick? You told me that this is actually optional if it's void?
Yeah.
So we don't actually have to put that there. We don't want. But just to stay consistent with kind of Java's approach to it, I'm going to put it there for right now. So I'm specifically saying I'm writing a function named display that I do not intend to return anything from. Prepositional phrase ending works out. Okay. All right, that makes sense? So now what do we mean to, what does it mean to display a person? Well, for right now, let's just display their, maybe like, hi, my name is, yes, I'm the real Slim Shady. Okay, so let's go ahead. We're going to do a println. This will let us practice our concatenation stuff. So we'll say, hi, hi, my name is, how do I, backslash open close parentheses, that's our placeholder for concatenation, right? And we're going to say self.fname, and then we'll go ahead and put a space after this. Let me go ahead and put our closing curly brace in there, or closing double quote. We'll put a space in, and then we'll do our backslash open close parenthesis self.lname. So that's what display will do. It'll say, hi, my name is whatever this particular person's first name is, followed by a space, followed by whatever this particular person's last name is. So I'll go ahead and create a second person. Say var p2 is equal to person. Let's see. Oh, here we'll do tater tot. He's got two nicknames. Tater Tot's the cute one.
Are we supposed to call me that when we're on the phone?
The second one was given when he was 4 hours late to the hackathon and had to drive 90 miles an hour.
Not 90.
But in his
95.
defense, he did. In his defense, he did show up.
I made it. Barely.
All right. So in any case, we've created two separate persons. So if I say P1.display, this will display the information about P1. If I say P2.display, this will display the information about P2. So let's see, can I actually view this? Whoa. That is, what is going on?
That ain't right.
I wonder if it's, let me just try something here.
Yeah, it's a good one. Maybe try changing the function from display. I don't know if display is like a
That's something built in.
Yeah.
Is it because it's technically trying to return a void and that's what you're getting?
Well, I took the void thing off thinking that was the problem.
Right, but you're still not returning anything, so it's trying to grab something for you to see to return rather than the print lens of the console. Because you don't actually see the console in this menu.
Yeah, hit at the top where it says 2 times. Is that displaying the right thing?
Top where it says 2 times?
On the right.
Oh, this guy?
Yeah. Where you're actually printing it.
Oh,
Yeah. Swift thing.
that's stupid. Good news is we won't be using playgrounds for that much longer. So this was just a thing, I guess, for right now. Hi, my name is Tater Tot. Hi, my name is Mike Lemon. All right, so 2 different calls. Man, that is stupid.
Yeah, it's like showing like what like the memory address of where the display function is or something.
Possibly. I think it's sort of kind of showing like the JSON representation of this object is what this looks like. So F name. So let's see if I can just click on that. Is that no? So this is the memory address, linker thing for it. And do I get a version of this where it shows me what this actually is, or is it just like bad like this all the time? There we go. Yeah, so this would be JSON representation for the object, right? But which is, I guess, interesting enough for 4 seconds. Whatever. All right, but there's our output. All right, so we have a couple of functions, and we have a constructor and a function that does a couple of things, or does one thing, display something. So let's give a let's give a couple other functions so you have something to kind of model your homework off of. So I'm going to say var age, and we're going to make age an int. So I'm going to make this an optional just so we can practice with optionals just a little bit. Don't get used to this. I rarely use optionals. Whenever Xcode suggests I make it an optional, I'll just say fix it and it does it, and then later on I use exclamation points so it ignores it. But what I'll do is let's go ahead and there's my name. Now we're going to, well, first let me go ahead and try to I'll put a space and then my age. We see we get a nil value here. We tried to use our age because that's the value that it hard-coded to when I didn't put any values in there. But what I would have expected it to do is scream at me saying this variable must be unwrapped before you can use it. Because what I was going to do here is I was going to do something, I was going to do like an inline if statement where I was going to say self.age. Oh, I need to, ooh, can I concatenate that in? That's going to be fun. Self.age colon. If there is an age, then we'll say I am self dot, oh, you're not going to be able to.
Yeah, do double.
Well, it's just going to get creepy pretty quick. Unimportant. I don't want to confuse what I'm trying to do here.
Is there a way to create in Swift? Can you have variables that actually do things in the getter part of it? Or
You can. So I mean, I could write a normal if statement here. So I'm going to say just.
So I guess like, can you have a variable and then have like a get and then say if null return this, if otherwise.
Yeah, it's essentially what I'm doing.
Right.
By writing this if statement here. I just thought I could pull it off with an inline thing, which wouldn't be great programming practice. But so if self.age, if we do have an age, this is the same thing as saying self.age not equal to nil. Equivalent lines. Then we'll say println I am years old. Self.age years old. It's going to yell that that's not a Boolean.
Apparently you can't display backslashes even if you wrap them in a string.
Do backslash.
Oh.
Okay, so if self.age is not equal to nil, println I am self.age years old. Fine. So now when we display, oh, here's our 2 times here. Hi, my name is Tater Tot. Hi, my name is Mike Littman. But now let's go ahead and set P1 age equal to 14. Now, oh, here's where the optional thing comes in. Here's our 2 times. Oh, it just shows it here. Oh, that is just stupid. I am, then it says optional 14, showing that age is actually an optional. If you wanted to not show optional there, we'll say self.age with an exclamation point after that. This says, trust me, there's a value in it. Make sense?
You're basically wrapping in an if statement that checks to see if it's null first. So then wouldn't it know that it's not optional?
You would think.
You think?
Yeah. I'd never write this. I would never write an if statement around it that checks to see if it's not nil. I would have written it like this. And if I should I do that, will that give me the error? See, I really want it to just give me an error. Like otherwise, what's the purpose of an optional?
Yeah.
Whatever. Let's not get hung up on it. It'll become clear to us later. But for enough to do your homework, we'll be good here. Okay. So, let's just get rid of some of this stuff. So we're going to go ahead and we're going to give ourselves a function for setting the age, even though you can set it directly. So we're going to say func set age, and this guy is going to take in a age of type int. It's not going to return anything. And let's see. Let's just do self.age is equal to age, whatever was passed in. All right, good there. Let's get rid of the displays. So now I can say P1 dot set age, pass it a value, so we'll pass that one 14. Say P2 dot set age, pass this one 21. And then we'll say, let's write another function that returns a Boolean. Okay, so this one's going to be the one that's similar to a couple of the methods you're going to write for your homework. So we're going to write a function called isOlder, and this guy's going to take in a person as a parameter. And it's going to return a Boolean. Where's the bool? Which one is it? The bool. It's going to return one of these guys. All right, and we want to say if self.age is greater than p.age. And we want this called isOlder is what I meant. Then we'll return true. Else return false. All right, so now, what's this guy? Non-void function should return a value. It's your first time being a compiler? I've already mentioned playgrounds are dumb, right? It's served a purpose for us here. Like I said, we're going to be done with playgrounds here like next class. So
it worked for me, so you might need to just put enter a few times.
yeah. So, but this is equivalent. That's fine. So isOlder. This guy is going to take in a person as a parameter, and it's going to return true if this particular person, the person who owns this isOlder function, has an age that is greater than the age of the person that was passed in as a parameter, and false otherwise. So now I can say P1 dot isOlder P2, and that should be false, right? Because P2 is actually older than P1. It is false that P1 is older than P2. But if I say P2 dot is older than P1, call it the other direction, that one's true. P2 is older than P1. Make sense how that works? It's head bobbing.
I found a good use for it.
It's funny. You missed a quiz. All right. So in any case, so just to kind of connect this to your homework, I just want to talk through this a little bit related to your homework because I really want you to just drill the syntax for most of you, since some of you are in 250 here, how this is going to connect to your homework assignment. So in our homework assignment, I'm asking you to create a fraction object that has both a numerator and a denominator. Just like this is an object named person that has an F name and an L name, and optionally an age, but for your fraction, you'll just have two, numerator and denominator, okay? Your constructor for your fraction won't take in two strings, it'll take in two integers for the numerator and the denominator, all right? Then I ask you to write a function to display a fraction, so pretty similar to this, except maybe a fraction would be the numerator followed by a slash followed by the denominator, something like that. So model it off of this display function. Then you should have a function for adding and subtracting one fraction from another. That's going to be like your isOlder function here. So a fraction, which is represented by self, can take in another fraction as a parameter and add that other fraction to themselves. So that'll mean find a common denominator by doing the cross multiplication stuff and all that jazz. Setting the final result equal to a new fraction. So instead of returning a bool, you're probably going to return a fraction. So you'll build a fraction inside there and spit it out. And how do we build a fraction? Just like we built a person right here. So you'll create a brand new fraction whose numerator is the new numerator, whose denominator is the new denominator, and return it. Finally, you're going to have a reduce function. Then the reduce function isn't going to take any parameters, because when I tell a fraction to reduce itself, a fraction already knows what their numerator and denominator is. So all they have to do is go in, figure out what the greatest common divisor of both of those are, and then divide them both. And now you can display that reduced fraction if you want, and it should be in reduced form. So no parameters to the reduced function, because the fraction already knows about itself. One parameter to add and subtract, that is the fraction that we want to either add or subtract to the fraction that called it. And then no parameters to the display method, 2 parameters to the initializer for the numerator and denominator. Make sense? All right, so that assignment's already up. So as you're working on it, if you haven't done Java and stuff before, this should make fairly good sense. You're just learning the new syntax. Watch the last couple minutes of the video as that refresher for doing the homework. That'll kind of give you that guided tour of how to go about it. Sound good? Questions, comments, concerns, bribes?
Done.
All right, I'll let you know as soon as the new version of Xcode drops. So we'll be at Alex's mercy until they're actually on the machines down there. But everybody should be able to get them on their own Macs. But I will wait until, are you confident you can get it on there at least several machines by Friday?
Oh yeah, for sure.
Okay.
I'll come in early.
I'll wait until Friday before I give you a machine that assumes there's an Apple Watch emulator down there. Okay? We might start with maybe an iPhone example or something like that. All right, I'll see everybody on Wednesday.